Hello. Just share my screen with you. And we'll begin. Hello, so my name's Michael Hobbiss, and I'm going to talk today about attention in the classroom and what I think are the best bets that we can draw from the research about how we can improve attention in our school classrooms. Firstly, I just want to say a big thank you to Nikki and Susie and all the other people involved in the Research Ed Norwich team for the incredible job of moving this conference online at short notice and all the work that must have taken. I think it's a fantastic achievement to have been able to go ahead with it, and thank you very much for having me. So my background is I was a teacher for 8 years, teaching primarily A-level psychology with biology and a few other things as well. And then over the past 4 years, I have completed a PhD at University College London in cognitive neuroscience, focusing particularly on attention and distraction in the real world, with a special interest in secondary school classrooms and the adolescents within them. Since January, having completed that, I've now been back in the classroom at Bourne Grammar School as head of psychology. So I am back in the classroom trying to put all of these things I'm about to talk to you into practice, and I can assure you I am aware that it is difficult, and moving things from research findings into real life practice is a challenge. But it's one that I think is worth doing in this case, as I hope to convince you. So first, I just want to start with a bit of background about why I think attention is so important and why I think we should talk about it more as teachers. I think as teachers, we often lament attention or the absence of it. We moan about distraction in the staff room, certainly I used to. And that sometimes is it, and perhaps it doesn't go much deeper to think sort of more structurally about what it is that's causing distraction and how attention might function and how we can structure the environment in such a way that it's conducive to paying attention. So I want to just sort of try to illustrate why I think attention is very important and is worthy of greater scrutiny and focus, and dare I say it, more attention from teachers. And then we'll move on to looking at the specifics of what we might do within the classroom. So in terms of the importance of attention, there are sort of two key features. There are more, but there are two sort of really key features that I think it's worth teachers being aware of. Firstly, is that attention is the gateway to every other cognitive process, to memory, to problem solving, to language learning, every other clever, higher order cognitive process that we as humans are so good at is dependent upon attention, as this model hopefully helps to illustrate. So this is a model of memory. It's quite dated now, it's from the late 60s, but it does a nice job of illustrating the point I'm trying to make. So this first store here, hopefully you can see my mouse, illustrates the senses. Basically, this is information that comes into our 5 senses from the environment. And this box here, which is called short-term memory, we would now generally more commonly refer to that as working memory, is where we start to process it and we can start to do more interesting things with that information. And what you can see is that in order for any information to pass from the senses into short-term memory, and then of course on into long-term memory, and indeed for it to then be able to be retrieved from long-term memory back into working memory, which in many ways is the goal of education, that we can retrieve something we know and use it in a new situation. In order for any of that to happen, attention is required to move information from the senses and the sensory store into our working memory. So attention forms a bottleneck, and if that is if information is lost there and the gateway is not open for whatever reason, then there will be no higher order processing, there will be no problem solving, and so on. Attention is utterly essential to getting information into working memory in the first place. So clearly it's important. But in addition to that, I think it's important to be aware that our attention is limited. Okay? It is a limited capacity resource. Now, it's very difficult to put an exact figure on what I mean, or how much attention or how much information we're able to pay attention to. It varies according to individuals and what the type of information is. But just as an example, in the experiments that I used to run on my PhD, where people were searching for letters in a display, often displaying 6 letters was enough to pretty much fill most people's perceptual capacity. And what that means is if you imagine you only have a certain number of slots in your attention, as this diagram helps to illustrate, there is only a certain number of things that are ever going to get in to working memory. And so, I mean, here, actually, there's probably more slots than I would have put in had I done this diagram myself. What that means is twofold. Firstly, if you imagine there are only a very limited number of slots in our attention, it means that if a student is paying attention to something other than what we want them to pay attention to, if they are focusing on task irrelevant material, this is not just a case of, oh, they're a bit distracted, but it will probably sink in anyways. You know, probably what I'm saying will go in there as well. That's not the case. If that attentional capacity is being filled by task irrelevant material, then it's highly likely that there will be no processing almost whatsoever of anything else. It just won't get in. So if your attentional capacity is filled by task irrelevant material, the task relevant material that you want that student to focus on will probably not be processed at all. Conversely, if you can get a student to focus on the task relevant material, and if your task relevant material, let's say it's these 3 ticks that we've got here, is helping to occupy and fill up their attention capacity, actually, not only do you get the benefits of that, but they will become resistant to distraction by other stimuli, task irrelevant stimuli, purely by virtue of the fact that their capacity is already full. So their capacity is filled up by the task. Actually, there's not much space to process anything else that's going on outside them. So that's potentially really valuable, and that's obviously that would be our goal as educators, to make sure that this very limited attention capacity is occupied by task relevant information. If anyone's interested about this limited capacity idea of attention, I've put some references there on the slide to work by Nili Levy, who supervised my PhD and who sort of spearheaded this, the theory of perceptual load, it's called. Not to be confused with working memory load, which is also obviously a big issue in education. That comes later. So there is a limited capacity in working memory as well. But this is talking about your perceptual or your attentional capacity, and which comes earlier in the processing stream. So that's one reason I think attention is really important. The other reason I think attention is really important is that that's the theory and that's how the system works, and then we can see the end effects of attention control on educational success. So we've got some quite clear evidence that attention directly impacts school attainment across the whole spectrum. And I'll show you what I mean by that with a couple of graphs here. So this is a graph from Christine Merrill and colleagues who work in Durham University. On the bottom, you've got inattention scores. These are scores scored by a primary school form teacher who will obviously see their students a lot and become very knowledgeable about them. And they complete a questionnaire about their attention skills. And that produces this inattention score. 0 means not at all inattentive, very good attention skills. Up to 9, very highly inattentive. On the and then that's plotted against attainment at Key Stage 2 in English and in mathematics here. And what you can see is that I think previously a lot of our focus, sometimes as educators, certainly in terms of my training, if attention was mentioned, it was to do with the very bottom end of attention. It was the clinical conditions, ADHD and so on. And of course, that's a group that is extremely important to focus on. But actually, attention is wider than that. And what you can see from these results is that really there's quite a linear relationship between your attention skills and how well you do in Key Stage 2 here in English and in maths. And you might say, okay, well, that's only Key Stage 2. That's a fairly early stage in their school careers. Well, here is a very similar piece of information. Again, these are teacher ratings of inattention when they were at primary school, now plotted against their GCSE point scores. This on the left for boys, down there, and for girls on the right. And again, what you can see is this same almost linear relationship between attention skills and educational attainment. So this is something which impacts educational progress across the whole spectrum. This is not simply an issue of a few people with a clinical condition. So what I've done there is I've kind of shown you things at two separate ends. One is at the very sort of fundamental cognitive side of how our processing works, and then the other is the end results of educational success. And what about all the bits in the middle? And that's where it starts to become a little bit patchier, because actually we have relatively little information about how this works in the classroom. We know attention's important. We know that students who don't have good attention skills don't do as well in education. But the bit in the middle, how, why, what is it that causes that, is very under-researched, and there's not an enormous amount out there to go on. The obvious question then is, for example, how distracted are students in lessons? And that's something that has been relatively little researched, but there are a few sort of conclusions that we can draw based on what has been done. A number of slightly older studies have used observational methods. So, in other words, a researcher or researchers will sit usually at the back of a classroom and observe the class. They'll often pick individual students and maybe move every minute to a new student, something like that. And they will observe the amount of time that that student appears to be on task, doing what they're supposed to be doing, or off task, doing something else. And there are variations in how these things are done and recorded, but that's the general sort of scenario. So here's one example of some results from a study like that, which found that elementary students were spending between a quarter and half of their time in the classroom off task, which is really quite a sort of staggering amount when you actually sit down and think about it. What that doesn't tell us, of course, is what they're off task on. What are they distracted by? What things are causing them to be off task? And that was something that really hadn't been researched at all. So on my PhD, I took the not particularly inventive step of asking students what things they were distracted by. So here's an example of some of that data. This is data from a secondary school in the northwest of England, 156 students between years 8 and 12, excluding year 11, who are away on study leave, with a sort of roughly equal numbers for each year group. And we asked them a very, very simple question, really. They came directly out of a classroom lesson, so they completed a normal classroom lesson, and as soon as they came out, they came to us, and we said, for how much of the lesson you were just in were you distracted by the following things, and gave them a number of different potential sources of distraction. And these are the results. So these are the mean percentages of time that they reported being distracted by the different sources that we gave them. So you can see that other people is the largest source of distraction here. That's 13%. Mind wandering and background noise, both just over 9% of the time. Then we've got two to do with technology, so social networking, and then other device functions, so that's non-social network functions on a computer or tablet or phone. Looking out of the window, and then displays in the room. Now, clearly there are methodological issues with the possible accuracy of students estimating the amount of time that they are distracted in the classroom lesson. So I wouldn't place too much store by the absolute accuracy of each of these numbers, but I do think there's a lot to be learned from them. Firstly, from the obvious idea that students feel that they are distracted a lot of the time. And whether or not the numbers are exactly correct or not, I think it seems very obvious that they are distracted a lot of the time. And not only are they distracted a lot, but they're distracted by a wide range of different sources. So that, I think, is interesting. It's challenging and to some extent worrying, I think, for us as teachers to sort of see that in black and white. But at least it gives us a bit of a handle on where can we start to look for improvements in what we do, where can we start to adapt what we do to try to maximize student attention. And so that's led me to try to put together a few of what I think are my best bets from the research. And as I've said, this is, in some cases, a relatively patchy research field. Attention in education is not particularly widely researched, especially at school level rather than university. But I don't think necessarily we should be afraid of that. If we assume that evidence is never the final answer, but should be used as the start of our journey, and we should use evidence as our launching point for us to then adapt our own practice and to assess whether it's working for us and make changes from there, then I don't think we should be afraid of a research literature which is a bit more patchy than some others. It just means our starting point is perhaps a little bit shakier, but it's still it's certainly worth doing. We've seen how important it is. And secondly, I still think it's relatively clear that these are likely to be the best bets based on the research that's been done so far. I should also say at this point that what I'm going to tell you about is purely from the view and the focus of maximizing attention. Now, clearly as teachers, we always have multiple different goals and things we want to achieve from our lessons. And sometimes you may well, and indeed sometimes I will, choose things which do not follow the recommendations that I'm going to give because I have other goals in mind for that lesson. That said, clearly, again, I hope I've been able to show that attention is incredibly important. So anytime there is new learning or anything like that going on, I think these should be borne in mind. However, there will be multiple ways that you might want to organise a lesson. Not all of them will correspond to the things that the recommendations I'm going to make here, and that's absolutely your prerogative as an informed teacher to decide when and when not to follow those. So I've got 5 best bets here for maximising attention, starting with background noise. So, background noise is an interesting one. When I was training, doing my teacher training, I was told a noisy classroom is a thinking classroom. And there was a very clear implication that quiet classrooms and silence were to be avoided, and that a sort of a riot of activity was an illustration of active engagement, but also of a great deal of thinking going on. And as I say, there may be times when that is the case. In terms of the research into background noise as a distractor and the effect that that can have on performance and learning, that doesn't seem to be borne out by the research. So background noise, for example, has been associated with reduced reading comprehension, reduced word learning. That's in adolescence and secondary school. Also, there's a slightly weaker finding, but also interesting one. This was with younger primary school age students. It was associated, background noise has been associated with reduced creativity. Now, usually in these experiments, background noise, it means speech sound. So this is background speech that's played to the participant as they do a task. It's not quite clear whether or not there might be some sort of threshold below which actually it doesn't make too much difference. There's some sort of indications that might be the case. And you know, that sort of chimes, I think, with what some of us might feel often, the sort of low hubbub in a coffee shop or something. Sometimes we can feel that's quite conducive to being able to work. But it's very clear that if that becomes too loud or too intrusive or too intelligible, and we are picking out words and we start to process what's going on in the background, then it does become very detrimental to learning. So it might be, as I say, that, you know, below a relatively quiet sort of background level of noise is not too harmful. However, my own thinking on this is that given that we know that there is a huge range in attention control skills between different people, most of this research is done on adults, admittedly, but there's absolutely no reason to assume it would be any different in children. There's a lot of individual differences. Some people have very good attention control. Some people really struggle with attention control. It's likely there's a spectrum of that in most, if not all, classrooms. Given that, and given that we don't really know where a lot of our students quite are on those spectrums, especially maybe if we teach them in secondary school and don't see them quite as often, and given that we can't tell to what extent or where that cut-off point might be for each individual student, so we can't be sure that actually the background noise isn't interfering for some students. My own personal position now is that I feel that if I have any deep thinking or any sort of detailed individual work that I would like students to be doing, which is going to involve some hard thinking, I want them to do that in as quiet an environment as possible, and ideally in silence. That's not to say that they can't then go on and discuss it with other people. So simple questioning methods like think, pair, share are things that I use a lot, and that allows them to think in silence for a particular amount of time, maybe even do answer a question in silence first, and then to discuss it collaboratively with groups, and then you get the benefit of both worlds, for example. Displays is my next the next thing to examine. This is always a perennial source of debate about how useful or harmful or otherwise displays are. It's worth bearing in mind that in my research, displays were consistently the lowest reported distraction source. So about 3% in the graph that I showed you, and that was similar in other samples that I took in different environments. But 3% is still going to add up to quite a lot of learning time over the course of a year or so, and marginal gains are are always good in education. In fact, we're in the business of trying to get marginal gains, aren't we? So it's probably still worth talking about. So here's an example of a study that's been done on displays. This is a study by Godwin and Fisher from 2011, where they compared a high visual distraction classroom environment, and you can see that on your screen now. So there were 2 students who came in, they sat at this desk here, and this was the high visual distraction environment with posters all over the wall, right in front of them. Now you can decide how realistic you think this is as a classroom environment, and whether a student would normally be sat with the posters absolutely right up in front of them and straight up the wall right in front of their face. But it's nice at least to see the sort of, there's an attempt to make a relatively realistic classroom environment. In the low visual distraction condition, the posters were just taken off the wall. And this was what they found in terms of their observations of how much time they spent off task and distracted. So the first thing to look at then is the environmental distraction, in other words, distraction caused by the things around them. Unsurprisingly, in the high visual distraction condition, the light grey bar, there's much more environmental distraction, all the posters and everything, somewhere sort of over 20% of the time, the learning time on average. That's much less in the low visual distraction condition. But, and this is a point for any of these tips I'm giving you, clearly this is not a silver bullet. On its own, this is unlikely to solve all distraction. We can see that from the peer distraction side here, because actually, when you're in the low visual distraction condition, when you take away those posters, you get an increase in peer distraction. So although environmental distraction was greatly decreased, you do have an increase in peer distraction. It's not to the same extent. Overall, students were still less distracted in the low visual distraction condition, but it shows that simply removing one source of distraction is not always going to be a guarantee of improving attention. So what's my best bet? What do I think can be gleaned from these studies, and there are others as well? Well, this is how I try to set up my classroom based on that research. The sort of front half and the front of the classroom, I as much as possible leave blank. Obviously, occasionally there are mandatory health and safety notices, fire escape things, and all of those, of course. But if I can, I leave the walls as blank as possible. The exception I make for that is if there is a display which is being referred to very regularly within the normal classroom routines. So it could be keywords or command words from an exam specification, or how to structure paragraphs. If there's something which is going to be very regularly referred to as part of the teacher's routines, and also ideally something that you want the students to start to use as a crutch themselves and to refer to themselves, then that will need to be visible. Other than that, however, I would try and leave the walls as blank as possible on that front half. And then I would put displays as normal on the back half and on the back wall. And hopefully then allow those displays to perform all the other functions of things that we like displays to do, such as motivation and providing examples of good work, information giving, and decoration, and so on. And it's interesting actually to think about that in even more detail. And I only got this thought through visiting Heathfield Community College in Sussex, where even the teachers' bookshelves, often we have our bookshelf at the front with our lovingly curated educational book selection that our partner won't let us keep at home. It might just be me. And actually this sort of, all of these sort of spines with their titles and their various colours visible to students, maybe we can go as far as actually thinking very carefully about where we even put all our books and where we put our where we store all our coloured paper and everything else, so that those things are not in students' eye line as well. Just a thought, it's something I'm playing with as I move forward. Okay, technology is the next one. Technology clearly is increasingly a ubiquitous part of classrooms. It's absolutely ubiquitous in higher education, which is where a lot of these studies were conducted. So there are some potential problems with how well that might translate to school classrooms, but I think a lot of the messages that come out of this are still very relevant. And the big finding, a very consistent finding, and it's not at all a surprising finding to come out of a lot of this research, is that the non-academic use of technology, so technology being used for purposes other than the main learning aim that they're in when they're in a learning session, is associated with reduced learning. It's hardly surprising. So that could be texting, it could be doing your Tesco online delivery order, it could be making your TikTok videos, whatever, but anything along those lines. But interestingly, the harm done to the learning is not solely borne by the person who is using the technology themselves. So other learners in the vicinity of someone who is using technology for non-academic purposes, people who are in the aisle, people who can see that screen, in effect, also have their learning impaired. So I think that's a really important point. If you are around someone who is using technology for a non-academic purpose, your own learning is likely to be impaired. And we can understand, again, why. It's hardly surprising. These are very salient stimuli, very bright screens, things moving about. So if someone's playing a game on a laptop just in front of us, it's going to be very difficult to keep our attention away from it. But what this means is, for us as teachers, if someone is not using technology for the correct purposes, it's not just a case of saying, well, it's their own progress they're harming. Oh, well, if they can't use it properly, then, then fine. Because it's not just their own progress they're harming. They are likely to be impairing the learning of other people around them as well. And students are sometimes a bit resistant to this. And this is something that I do discuss with students, and I would recommend discussing with students. A lot of the time, it comes down to a misunderstanding on the part of students about their ability to multitask. So some of these findings about technology use are clearly about distraction, but others are about multitasking. It's the illusion of doing two things at once. And that's something that as human beings, we feel we're very good at, and actually we're very poor at. And in fact, we really can't multitask at all. What we can do is flip backwards and forwards between two tasks. And each time we do the flip, there is a cost to our understanding or to our efficiency. Students often don't know this. And one of the reasons they don't know this is that these devices are designed to make us multitask. That's how they operate. That's how they make their money. They want lots of apps running at the same time. They want multiple screens open and tabs open. All of these things are just normal parts of our life, but actually they're inciting multitasking. Students think that they can do these things and pay attention to some other source as well. And it's important, I think, sometimes to discuss the limitations of their attention and their inability to multitask in order to put in place the right structures and the right usage for technology. And when I now use technology in the classroom, I try to do it in a very tightly structured context. So I will only, for example, send students to defined websites and to do very specific tasks. Internet research is something I used to set students, and I would never do that anymore. Ideally, I know this is not always possible, using devices designed for educational purposes. I am very keen on encouraging students to take notes on paper rather than on devices. Another consistent finding is that students using technological devices take fewer notes than students who are writing them by hand. It's not entirely clear why that should be, but it is a consistent finding. It may again be just due to multitasking or due to the idea that perhaps you don't need to take the notes to quite the same degree because of a sort of overconfidence about having resources in front of you on the screen. So paper note-taking. Clearly, some students require devices. They need those for various learning aids in different conditions. when I have students who have those requirements, I try to sit them in places where that screen will not impact other students. So the back row, for example. Okay, a couple more. Mind wandering. Mind wandering is a funny one because, of course, we can't see it. And all the other distractions, at least as teachers, we can sometimes get an idea that they're going on through behaviour. Mind wandering is by definition internal and therefore to some extent out of our reach. Unfortunately, it seems to be very prevalent, perhaps more prevalent than we might think. So these are my findings from the graph I showed you before, which showed that mind wandering was reported by secondary school students just under 10% of the time. In universities where this has been a bit more studied, they often use what's called a probe question, which is very simple. They just send a question to a device, a student device, which says something like, are you mind wandering right now? Yes or no? And when you ask them like that and send it at random intervals throughout a lecture, very consistently, they seem to get responses somewhere between sort of 30 to 45 or even 50% of those probe questions get a yes response. So they report mind wandering. It's not quite the same necessarily as mind wandering for 30 to 50% of the time, but it shows that it's very prevalent. It's going on a lot. And that's a real worry. There's also a potential problem in that there's some evidence that mind wandering it will increase in places where other distractions might decrease. So very quiet environments possibly increase mind wandering. So again, no one of these ideas is going to be a silver bullet on its own. So mind wandering, what can we do about it? Well, it's difficult, but one, again, consistent finding seems to be that self-reported interest in the topic seems to reduce mind wandering rates. I found this on my PhD, and a number of other people found it as well. I also found that interest in the topic reduced other external distractions as well, but mind wandering was the strongest relationship. So ideally, we want students to be positively engaged and interested. Easy to say, I know. I do think, however, that perhaps engagement maybe is easier than interest there. And we can try to perhaps make sure that students are engaged with lessons through the use of appropriate questioning techniques and the right discussion, so that all students are indeed engaged in lessons. Hopefully that might reduce mind wandering. My final one I want to just very briefly mention is teacher talk. There's sometimes we hear about the 10-minute rule or various minute rules, the idea that we have a limited attention span. Just very quickly to say that that is not supported in research. Attention certainly does fluctuate, and over the course of a lesson it will probably go down, as you might expect. But the differences between students are much more important than the differences than any particular arbitrary cut-off figure. So, as a teacher, if you want to talk, then talk. However, one thing you might want to do is to check for understanding at regular intervals. So, people who interpolate, in other words, put at various intervals checks for understanding or little quizzes or tests, when that's been interpolated into experiments that have looked at learning, not only do people remember what they've learnt already better, but interestingly, they learn new material after the test better as well. And they report reduced mind wandering, so better attention in addition. That's known as the forward testing effect. It's a sort of spooky effect where a test can make you better at learning new things afterwards. So I would interpolate, and I now very much try to interpolate checks for understanding into explanations that I give. Okay, I'm running slightly out of time, so I'm not going to talk about my final slide. But just to say that a lot of these thoughts are also recorded on a blog that I wrote with the same title as this talk, which is on my blog, which also includes links to all the papers that have been referenced in this talk. So please do look them up. I'd be very keen to hear from any viewers if you have any thoughts, or if you're interested to do any attention research. I'm still keen to continue researching. So please do get in touch if you're interested. Thank you very much for listening.